there, and welcome to 1-2 Systems of Equations. This time we're solving by substitution. So go ahead and write down the title, 1-2 Systems of Equations by Substitution. Put your name, that top right-hand corner, and today's date. And then below our title, we'll start with our learning targets. And just to remind you, you can push pause anytime you need more time to write something down, and then push play when you're ready. So our first learning target is that I am learning to determine solutions to systems by substituting, and I am learning to solve systems of equations by substituting. So the big thing with substitution is that this means today we're going to solve it algebraically. And what that means is that we're not going to graph today. So we're still going to look at solving systems of equations using just algebra instead of having to graph it on a coordinate plane. So now with our systems, we still end up with our three types of solutions. So solutions of systems are still those three types, except today they're going to look different because where we're going to solve them algebraically, we won't be able to look at the graphs. We'll have to look at our answers. So the very first type is one solution. If you think back to graphing, that's where they do intersect, and it is a point of intersection. So we write it like a point, x, y. Now, the way that will look today is you'll end up solving an equation, it looking like x equals 2, y equals -3, and then having the ordered pair as your x value is 2, your y value is -3, and that's your answer. Our second type of solution we can get is no solution. And if you remember from graphing, no solution is when your lines are parallel. There's no point of intersection, so you put the circle with a line through it for no solution. Now this is different. It's going to make you think back to Algebra 1 for a moment, because you're going to have, now algebraically you'll end up with a step somewhere along the line that looks like 2x minus 2x equals 8 minus 6. So 2x minus 2x is just 0, because 2 minus 2 is 0. You don't have to show the x, because 0 times x is still 0, and so it's just 0. 8 minus 6 is 2. And you have to ask yourself, is that true? Does 0 equal 2? No, it doesn't, because 0 has to equal 0. So since that statement is not true, and it is not equal, so not equal, it is a no solution. So you put a circle with a line through it, box it in, that's your final answer. And the last type of solution we can see is infinite solutions. And remember from graphing, infinite solutions is when we have the line that ends up being the same line and we put the infinity symbol. Now for this one, it looks a lot like no solution, but it solves out differently. So you end up with a step that looks like 2x minus 2x equals 8 minus 8. So this time, we remember 2x minus 2x is 0 equals 8 minus 8 is 0. So since that is true, 0 does indeed equal 0. That is true, it's infinite solutions. So that's your final answer we put. So those three different types of having a point, no solution, infinite many still occur algebraically. Now let's look at how to solve systems by substituting. So the very first thing we have to do is make sure one equation is solved for one variable. And when you think about it, that means that one variable is alone, it's isolated. So all those different words also work. So you want to make sure it's solved for one variable, or that one variable is at least alone on one side or isolated on one side. All of that means the same thing. Step 2, and here's where you have to pay close attention at step 2. We're going to go back to the name of the game today, substituting. So we're going to substitute. Remember, substitute just means we're going to replace. Oh, it jumped on me. See if you'll go back. There we go. Substitute. The value for the variable and that's step 1. So where you have your variable isolated into, and this is the most important part, other. equation. So anytime you substitute a value for a variable, you have to make sure you put it into that other equation in the system. Alright, step 3. We're then going to solve for the remaining variable. So if you think about it, at step 3 here, where we solve for that remaining variable, we're only going to end up with something like y equals 2. So if you have just one variable solve for, that means we're going to have to substitute again to find the other variable, just find x. So once again, name of the game is substitution, so we're going to substitute again. So substitute. Or remember, that just means to replace the value for a variable. And remember, that's the value at step 3 into original equation. Now the last little part here, so if we solve for the other variable here at step 4, so when we substitute that value for the variable from step 3 into original equation, we're going to then solve for other variable. And when you do that, then you have like your x equals 3. So then, if you notice, like you then have a y value, you have an x value, so your last step here is to write answer as, and then we either want to write it like the order pair x, y. So for like that one, it would be positive 3, 2. Or you want to write the no solution if that's what you got. Or, I don't know why I put a comma instead of the word or you're infinitely many. Some of you all may have noticed I had a slight magic just a second ago because I realized I did not have enough room to write out all of my step 4, so those of you all noticed, good job. Alright, let's look at example 1 here. So we have y equals 4x plus 3 and y equals a negative x minus 2. So we're still looking at substitution, which means we need to have one variable already solved for, which means a lone on one side of the equation, one side of the equal sign. So if you notice, both of these have y by themselves. So that first one says y is 4x plus 3. So since y is 4x plus 3, I can replace this y with that 4x plus 3. Now another thing to think about this one, where it's a different type of substitution, is that we know that these two y's are the same, because it's y, of course. So since y does indeed equal y, we can take these two parts that they're equal to and set them equal to each other. So I can say my 4x plus 3 and replace this y with my 4x plus 3 and set it equal to what this other y equals as negative x minus 2. So we just take what each y equals here and we set them equal to each other. So 4x plus 3 equals my negative x minus 2. Since y equals y, these two parts can equal each other as well, so just put an equal sign there in the middle. Now it does become an equation, and for this one we have to remember that we want to take variables to the left and then we want to take the numbers to the right. There you go. Perfect. Okay, now, since we're talking to take variables to the left, I already have a 4x here on the left, so he just drops down, 4x. Now I want to bring all the other variables to the left. So since my negative x is on the right side and I bring him over here, he's going to change his sign to a plus x. We drop down our equal sign right there in the middle. We drop down our negative 2 because he's already on the right. Numbers stay on the right. And now I need to take this other number to the right. So my plus 3 now becomes a minus 3. So now I have 4x plus, there's a hidden 1 there, so 4x plus 1x is 5x equals negative 2 minus 3 is a negative 5. Now we're going to divide both sides by 5. 5's cancel, and x equals, and negative 5 divided by 5 is a negative 1. Very good. So I now know x equals negative 1. What makes this one now different from the ones we've seen is that we now have to solve for y. So I'm going to erase all this up here at the top where I showed my scratch work and just say that we have to grab one of these. It doesn't matter which one we grab. So I'm going to grab my top one here. Grab that top equation and rewrite it to the side. We have y equals 4x plus 3. Now we need to solve for y, so I'm going to have to replace my x here with what we know x over here equals. So since x is negative 1, wrong marker there, I thought I had the highlighter. Since x is negative 1, I can replace this x with negative 1. So y equals 4 times x is now be 4 times x is negative 1. Drop down my plus 3. And now this is just order of operations. We have to do 4 times negative 1, so we always have to multiply first. And 4 times negative 1 is negative 4. Drop down our plus 3. And now we're good to add. Negative 4 plus 3 is going to be negative 1. There we go. And now, just like we did last week in our practice work, we're going to have to write our answer as an order pair x, y. So our x value, we got negative 1. So negative 1 comes first. And our y value, we also got negative 1. So the solution to this one is negative 1, negative 1. So we had to set each piece equal to each other. So we had to do our 4x plus 3 equals our negative x minus 2. Take variables to the left, numbers to the right, and then solve for our first variable. Then we had to substitute again. So substitute second time to solve for my y. I had to replace my x with the negative 1, and then just from there multiply and add. So let's see another example to make sure we're all good. So example number 2. We have y equals negative 3x plus 4 and y equals 3x minus 2. So remember, first step is to make sure we have one variable solved for an equation, so that y is all by itself, so I know y is negative 3x plus 4. So then I can replace this y with that negative 3x plus 4. Also, if you remember what we just talked about that last example, we know for a fact that y equals y. So therefore, I can set these two parts that they equal and set them equal to each other. So I'm going to replace this y with my negative 3x plus 4 and set it equal what this other y equals, my 3x minus 2. And now remember, we said we want variables on the left and our numbers on the right. So since my negative 3x is already on the left, he has the variable, he just drops down as negative 3x. And now I need to bring over my positive 3x, so he also becomes a negative 3x because he jumps the equal sign. My negative 2 is already on the right, so he's just going to drop down negative 2. And now my positive 4 is going to become a minus 4 because he jumps the equal sign. And now negative 3x minus 3x is a negative 6x equals negative 2 minus 4 is a negative 6. Divide both sides now by negative 6 to solve for x. Negative 6's cancel and x equals negative 6 divided by negative 6 is positive 1. Alright, so we're halfway there. I now know x is positive 1. We still need to know what y is. So I'm going to once again grab my top equation here. So y equals negative 3x plus 4. And this time, I know that x is 1, so I can replace this x with positive 1. And just substitute again. So I'm going to say y equals negative 3 times x is going to be negative 3 times 1 plus 4. And y equals negative 3x times 1, sorry, just negative 3 now. Negative 3 times 1 is negative 3 plus 4. And negative 3 plus 4 is positive 1. So this one's a lot like our last example in that when we go to write our final order pair, x and y, they're the same value. X here is positive 1. And then our y here is also positive 1. And we're all good. That's our final solution, 1, 1. Now we'll see one last example for today. So the first thing we look at to see is if we have one variable solved for. So one equation with one variable solved for. And if you look, this one we do. We have y equals, by itself, 4x plus 3. But if you look down here, I also have y by itself equals 2x minus 15. Now here's the cool part about this one. I really like these type because we know that y equals y. We know that part's true. Y equals y. So we can actually take what they're equal to and set them equal to each other as well. So I'm actually just going to replace this y with the 2x minus 15. So y is now going to be my 2x minus 15 equal to what that first y equals, 4x plus 3. 4x plus 3. So we said the y equals y is true, so then we can take these two parts and set them equal to each other. And it doesn't matter which way you can do it. You can put your 4x plus 3 over here and your 2x minus 15 over there. It doesn't matter, as long as they're set equal. And now that we have both equations set equal to each other, we're going to take our variables to the left. So 2x is already over here on the left side. Bring over our positive 4x, make him a negative 4x. Drop down our equal sign. I always like to try to keep it in line with the other one. We have our plus 3, so positive 3 on the right. Our minus 15 over here to become a plus 15. And now we're good to simplify. So 2x minus 4x is a negative 2x. 3 plus 15 is 18. Divide both sides by negative 2. Negative 2's cancel, and x equals 18 divided by negative 2 is negative 9. Now that we have x is negative 9, we can replace one of these x's up here. So I'm going to grab that first equation. For this one, it doesn't matter where they're both set with y equals. So it doesn't matter which one you ever grab. They both will solve out correctly. It's just one's usually a bit easier, but in this case, they're the same because they both start with y equals. Now we're going to replace this x with the negative 9. So it's going to be y equals 4 times x is going to be 4 times negative 9 plus 3. 4 times negative 9 is negative 36 plus 3. Negative 36 plus 3 is negative 33. And now our last step is to write our answers in order pair. So x always comes first, so negative 9 and 33. Sorry, negative 33 for our y. Quick little statement about this solution is that think about if you were to graph both of these linear equations on a coordinate plane, they would eventually cross at negative 9, negative 13. So rather than having to make a coordinate plane that big, we just solve it algebraically.